guys ready? Then we can start. So today we're doing a new chapter, 8.2. So what's the title of today? So integration what? By parts. So this is a new technique. Remember, we know what? We know how to do power rule. We need to do what? Product rule, that's right, quotient rule. We can do a chain rule. We have use substitution rule. But we're going to introduce what? New one today. What's that called? Integration by part. All right, that's another one. But you know calculus, you know mathematics. You have to still utilize what? Your previous what? Content knowledge. So I'm teaching you new technique, but new technique also uses what? Your previous knowledge. Okay, so now let's do it. Okay, those formulas, you can write it down in your notebook if you want to, because you want to do your work. But on your exam, I will give it to you. I will provide you. Okay, because I'm not really big into like memorizing all these formulas. I am more into understanding and how to utilize the information that you have. Okay, because like you have to understand. Like even I give you formula, if you don't have understanding, the formula means nothing to you. Because you have to understand to utilize the formula. So understanding is very important to me. Okay. All right. So now, so bad about this. When I make it really big, then I cannot see. Okay. Let me see. Okay, I will stay with this. Okay, so let's review the basic integration rules. The basic integration rule. So, did everybody see this? Okay, integration of k f of x. K is what? Just some constant. Then what do you get? That's the same as you can put the k in the front of integration and then the what? F of u, which we know that, right? The next one, what do you know? F of u plus and then g of u, that means what? You have two functions, you add it together, then you can make it into two parts. F of u plus what? G of u. We already know that, so nothing new. Next, if you have a constant, integration of nothing du. So what is really mean here? You have what? 1, am I right? You have a constant called what? 1. So that's the same as 1 times du. That's why you have what? X plus what? C. Is everybody with me? Okay. Just like if I have 3, du means what? 3x plus c. Okay. Okay. Next one, you know, this is what? This is a power rule, right? Did everybody see that the next one? Number 4, it's just a power rule. So if it's a derivative, you add, you do what? You subtract the power and then multiply by the power, right? But if it's your integration, what do you do? You do exactly opposite. So what do? You add the power and then what do? The power then divided by what? The power. Is everybody with me? That's why it's called power rule. It's still power rule because you're doing a what? Same power rule that you're using as the derivative, but you're doing as what? Integration, as opposite. Okay, what's next? Okay, this is the one that you're supposed to memorize, so you don't have to keep looking at this. There's one occasion that you cannot use power rule. Why? If you have this, what is that equal to? That's the same as u to the -1 power, isn't it? So if I use the power rule, you get -1 plus 1 plus what? -1 plus 1. You get what? U to the 0 over what? 0. Can I have a 0 as a denominator? No, it's undefined. Nobody knows what that means. So we know this special case. If it's a -1 power, well, it looks like this. That actually really means what? Natural log of u. You're supposed to know that, right? You're supposed to know that. Okay, same thing. You need to know what? Number 6, you need to know this. Those two we use all the time. Just go and memorize it, okay? So integration of e to the u is what? E to the u, exactly same thing, okay? All right, integration of a. Okay, u is a special number, 2.7. That's an irrational number. But how about we use other number? So a means any number. Like if I say 2 to the, say, x du. That's what that means. A is any number. Okay, e is a special number, right? E is 2.713, that irrational number. But if I say a, any number, okay, then what is it? You would do what? 1 over natural log of a times what? A to the u plus c. Is everybody with me? Okay, so this is actually same thing. Look at this. The natural log actually applies same thing. This is the same as, look at this. This is the same as 1 over natural log e to the x plus c, or u. Okay, but this happened to be what? Natural log of e is equal to what? 1. So this is the same as 1 over 1 e to the x plus c. That's why you just have e to the x plus c. Okay, but you cannot do that with a. 1 over natural log of a is not 1. Well, a happened to be e, then it'd be what? 1. Since it's not 1, you have to write down what? 1 over natural log of a. Okay, is everybody with me? Okay.
So the a is any number.
Yes, any number. So if I give you this, what's that equal to, Wyatt?
So 1 over.
Okay. And then, that's right. Does everybody see that? It's any number. Okay. All right, now sine, memorize this. Natural log, I mean the integration of a sine is the same as what? Negative cosine, which makes sense, right? If you have y is equal to, say, cosine x, what's y prime? Negative sine x, right? So if I give you opposite, if I want to go back up, what do? You take what? Integrations, right? So if you go back up, if you have a negative sine x, you get a what? Cosine. So if you have just the sine x, then what do you have then? Negative cosine x. Is everybody with me? That's why you have this negative. Okay, which is the example that I'm going to do today. That's what I'm going to do. You have to take antiderivative of a sine, then you're going to say that negative cosine. Okay, all right. Let's move on. So cosine is sine. Why? Derivative of a sine is what? Positive cosine. So antiderivative of a cosine give you what? Positive sine. Okay, this is the basic things you need to know. Okay, tangent u. If you don't want to derive this, you can just memorize. Antiderivative of tangent is what? Negative natural log cosine u. So class, you need to know all these things. These are the ones that we use all the time. So just go ahead and memorize if you want to. So you don't have to keep refer to it because you use this all the time. But I will give it to you. I will give it to you this as a part of your exam. So I don't mind providing you with these formulas. All right, so cotangent is what? Natural log of a sine u plus c. Okay, look at this one, number 12. Integral of secant is what? Natural log of what? Secant plus tangent. Okay, I want you to familiarize with your integration of trigonometry function because 8.3, I do a lot of trigonometry functions. Okay, 8.2, we do integration by parts. 8.3, we're gonna do trigonometry functions. How to integrate higher power of a trigonometry functions. All right, cosecant and secant square, we use that a lot, right? Integration of a secant square is just a tangent. Integration of a cosecant square is what? Negative cotangent. So now look at this, the bottom one. So I want you to also remember this. This is what I'm gonna use on 8.3. A lot. So look at this. Integration of square root of a squared minus u squared. What is that equal to? arc sine u over a. Okay, a is what? Some number. What's u? It's a function. Okay, it's a variable. Okay. So if I give you this, let's make an example. Then what's that equal to? Apply that formulas. What's that equal to? So I'm using our example 18. So what's that equal to then? Arc sine. U is, what is my u? Just use u. What's a? Okay, a squared is 9. So a has to equal to what? 3. Okay, what's arc sine? How can I also write down arc sine as? Sine and then what? Inverse, right? So they're saying sine inverse is the same as arc sine. They're the same thing. Okay, your homework, you can write it either way. They're correct. Either way is correct. All right, so I want you to look at the number 19. You see that? A squared plus u squared is the same as what? 1 over a, arc tangent, u over a. One more, this is the second one, it's kind of complicated. 1 over u times square root of, look at this, u squared minus a squared, and you have this, 1 over a, arc secant, absolute value of u divided by a plus c. Okay, so that's the basic integration that we have learned up to chapter 5. Okay, there's other techniques that you have. This is just some techniques that you can use. So I want you to look over this instead of I'm explaining, because like sometimes you have to explain to your work. Sometimes separated into 2 different numerator. Okay, the common denominator, and then what? 1 over x squared plus 1, and sometimes what? And then what? X over x plus 1. So you have to separate the numerator. That's other also what? Complete the square and divide the improper rational functions, add and subtract the numerator. This is a different techniques that you have to use. But right now, okay, this is the one that you need to know a lot. We're gonna use this one a lot. Okay, trigonometric identities. It's very important. 8.3, I use that a lot. Okay, 8.3, so you have to know your identities. Because you don't want to look at it, you have to kind of familiar with your identity. I want you to look into it, okay? Kind of know it, so you know how to utilize it.